All right. All right. Let me go ahead and share my screen. Okay. Okay. All right. Let's see if we're on target here. Okay. I'm going to go ahead and get going here. Okay. Hello, everyone. My name is Alan Ware. I am a mechanical engineer. I got my Bachelor of Science in Mechanical Engineering from Bradley University in 2007. Before I worked for Rockwell Collins and other various construction subcontractors. I currently do work under the business name of AMW Design. My website is www.amwdesign.net. I previously taught 3D printing at Sierra College. I've been very involved with Hacker Lab, Sacramento-based hacker and makerspace, teaching classes there and helping them out with various projects. I'm also a co-founder of Operation Innovate / Code for Hood, a nonprofit focused on youth and STEM education. I'm very active with Green Technical Education and Employment, another nonprofit organization whom I teach a programming / digital literacy class. We were doing it in person before COVID, but now we're doing it online Tuesdays, Thursdays, and Saturdays. I was participated in the AgSum Harvest Hackathon about 3 years ago in Tokyo, Japan, and was a finalist in the first round of that and got a free trip back to Japan. And most recently, I have been on a show on Disney Plus, Shop Class, Season 1, Episode 4, Bridge or Bust, which is actually kind of embarrassing when I go back and look at the episode, but whatever, it was a good experience. So generally what I do is I just make stuff. So these are just various things that I've made or designed in some capacity. Generally, I do a lot of work with processes. Basically, if you're going to make something using a computer, so CNC machines, 3D printers, laser cutting, so basically computer-assisted manufacturing. So here goes the breakdown. So what I tell myself is that I help people make things. What I've said in the past is it's going from a drawing on a napkin to 3,000 units made in China. Anything you need across that, I can do. What I tell other people is I do nerdy stuff for money. AMW Design provides services including, but not limited to, computer-aided drafting, 3D modeling and mechanical design, mobile application deployment, educational services, prototype design, and manufacturing consulting. And that's what you'll find on my website. So my target audience for my services is generally entrepreneurs or small and medium-sized businesses, basically looking for individuals who are looking for a little bit more of like a little technical help, some engineering support, but they don't have the resources on hand to support it. So that's generally what I do. So tools of trade. So as I mentioned before, I am a mechanical engineer and I do a lot of computer-focused stuff, so I can do a little bit of programming. I work with a lot of computer-based tools, but at the end of the day, I do a lot of design work. And as I do a lot of design work, I'm a huge fan of pencil and paper. So I really like the tangible nature of it. There's a really big ad for getting for it right now, but it's not salient. But I really like the idea of just kind of putting my ideas physically on paper. Like, I think there's an obsession with computer stuff, rightfully so, because it's very, very powerful. Lets us do a lot of stuff very quickly and with few resources. But I'm still just a big fan of being able just going quickly from my mind to paper. It's something that I find very, very, very useful in the design process. So as much time as I spend on the computer, I definitely spend a lot of time, drawing and laying stuff out, triangles, circle templates, and things like that, compasses, because I can't draw a straight line. Well, I'm getting better at that, but I used to not be able to draw a straight line. So so a lot of that helps. And I think it's still, even as we think about all this stuff that's computer focused, I think there's still very, very much a place for pen and paper and kind of the physical, tangible nature of things. So what I want to do is I want to go in right into design engineering and kind of talk about what is design. So I'm very big on definitions. So what I want to do is I want to pull together a couple of definitions of design and kind of use that as a basis to move our conversation forward. So what is design? Design is to pull together something new or arrange existing things in a new way to satisfy a recognized need of society. I think that recognized need of society is a really important concept because we design things. I like to think of design as desire made manifest. Like we make things to satisfy some sort of purpose. We make a chair because I need a place to sit. We make a desk because I need somewhere to sit. We make buildings to live in and work in and things like that. And a lot of times we make these machines to address some need of individuals. And as design engineers and as manufacturers, that's really core to what we do and what our kind of purpose is. So, you know, it's you can work on something and you can get so focused on just doing the work, but especially with design engineering, designing and fabrication and manufacturing, I think it's always important to keep the larger scope in mind. Another way to think about design is to fashion after a plan, and then to create something that has never been. I really like that one as well. So when we think about, you know, while I'm definitely can operate in a scope larger than manufacturing, we definitely want to focus on that right now. And I guess the big thing, if I had to really break it down, what I really like to try to express to people is that making stuff is hard. It requires a lot of communication, a lot of collaboration. And as a design engineer, you are the one that is creating that plan. You are setting the path of work that people are going to go ahead and follow. So there's a lot of responsibility that comes with that, but there's a lot of power as well. And if I say, like, a lot of freedom. So I think to, you know, become a design engineer, or to kind of go into that, you're kind of taking a lot of that on, because everybody can go and, like, you know, follow orders, but you're really the one that's really kind of laying out the path, or you're part of the team that's laying out the path, which is actually probably a better way to describe it. So what does a design engineer need? So what's really important is this idea of communication and collaboration, which is funny because we don't always think of engineers as skilled communicators, which is sometimes true. But as I just kind of spoke to before, communication is vital to the efforts of design, especially with manufacturing, because you have a lot of things that are getting put together to make something. You think about, like, an Xbox or a cell phone. You think about all the different parts of that. Somebody has to make each one of those things, and then somebody else, or the same person, has to think about how all of those parts fit together. And if one of those parts doesn't fit properly, or if one of those things doesn't fit together right, then the whole thing doesn't function. You know, and one of the interesting things about design is, I think one of the hallmarks of good design is that you don't notice it, because you will always notice it when it breaks, but when it works, you don't even think about it. And that's kind of one of the hallmarks of good design. And there's a lot of work that goes into that. It goes into, like, giving something that natural feel. And I think that's something that really attracts me to the field. Another thing that a design engineer is going to need is to be flexible and adaptable in their thinking. So a lot of times when you're building off of something, you're always going to build off of something that has come before. You know, I think it said like good artists borrow or great artists steal or something like that. But, you know, we look to the world around us and we draw on our experiences for inspiration. But the thing is that there's always going to have to be something new to add to the mix, because otherwise, why are you involving it? Why are you involved in it? If we're just going to take off what was coming and reuse it, we're just going to do that, and there's no designing that needs to be happening. So to really kind of zero in on this idea of to create something that has never been, I think there's two parts that you need for that. You need the courage to propose new ideas and novel solution, but you also need the discipline to analyze and vet those submissions to make sure they can work properly and effectively. So to speak a little bit more to kind of what I do and how I kind of satisfy those communication requirements. So I do a lot of things with computer-aided drafting and computer-aided machining. I'm more on the design side, but I also do some fabrication as well. And one of the ways that I can often communicate my work is through detailed drawings. So through these detailed drawings, I'm often creating things from, like, a 3D model. So I'm drawing this using some sort of 3D computer-aided drafting tool, and then I can use that to create a detailed drawing. And then that detailed drawing gives valuable information about whatever it is, the thing that I'm trying to get fabricated, such as the size, shape, significant dimensions, and manufacturing instructions. So the idea here is that with this drawing that we have right here, there's all these pieces of information that I could give to a manufacturer, and ideally they should be able to make it without my input. Things like the dimensions, things like hole call-outs, what size the hole needs to be. If there's a screw, you know, you hear about 440, there's screw standards as far as how big they are, the material, just all these pieces of information to go and make someone do this, because I can do this once, and then I can give this to a manufacturer, and then they can make 100, 1,000 of these, or how many they want to. But I have to make sure that it's done right, because any sort of problem that I introduce into it can be magnified. So there's a lot of checking, and there's a lot of kind of really that validation, you know, and that's why I kind of speak to discipline when it comes to this field. Another way that we can communicate these designs is with exploded views. And with exploded views, these give a representation of how pieces fit together. And it also kind of assists with the ideas of individual components. So again, I'm going to always go back to this idea of visual representation, because that's really what it takes. I mean, it's really all comes down to effective communication and whatever tools I can use to to ensure that. So with this, you have all the different pieces of this assembly showing how they fit together to assist an assembler, or maybe if we're just in the idea phase, so that I can express to someone else what I'm trying to build, and then we have something to talk about to use as a frame for discussion, say like, hey, I think this part needs to go here, or we need to put this part here, or this shouldn't go here because it's going to interfere with this. This is all what is kind of wrapped up with the idea of design engineering. And I'm talking about this in a physical sense, but this can happen with anything. This can happen with electrical stuff. This can happen with the program, just anything where you're having to create a plan and build something. These sort of these activities are going to come in. They're just going to manifest in different ways. Since we're talking about manufacturing, we're specifically talking about the physical objects that we're creating. Then the last thing is the bill of materials. So a bill of materials is a listing of the parts that make up an assembly. So one of the funny things is that, so we have this part, which I've shown different images of. Are we good? Okay. So we have this part that we've seen images of, and really what I'm doing is I have to specify everything that makes up this thing down to the screw. And so it's really that kind of again, that discipline and that detail, because with this specific thing, with this specific part, I have to think about, well, man, does this screw need to be a ½ inch long, or does it need to be 3/8 of an inch long? And these are decisions that come into play. Another thing which comes into play a lot, especially kind of reinforced by where we find ourselves right now, is this idea of sourcing, like where these parts are going to come from. One of the things that COVID has made us really think a lot about is where things are coming from, where our supply chains are, because it's disrupted a lot of stuff. And so again, going back to this idea of manufacturing, we've done so much with like outsourcing and getting things done overseas. A situation like what we're dealing with right now really kind of reinforces the fact of why it's important to make things here. And well, if we're making things here, what does that mean? Manufacturing. So there's a lot of opportunity and a lot of work to be done here, because even with the short memories that we can have as a collective society, right now we're all a lot more aware of why it's important to do things where we are. And I think that provides a lot of opportunity for manufacturing and related efforts. And as we said, it's a collaborative effort. So there's a lot of different things. I mean, you can be involved with manufacturing and never have to pick up a pencil. I mean, I never have to draw a thing. Processors, planners, it's all collaborative work. So to talk about how I got here. Whoa. Okay. I think we got some feedback. Okay. Somebody.
That wasn't for this. Just checking in here. How are things going, Alan? This is Kevin McGrew.
So, Kevin, this is Dean. Can you hear me?
Yes, I can.
Okay, so it looks like Alan went on mute. It would appear that Chris Stinson gave the Teams link to his entire class.
Okay.
And that created some problems because then all of a sudden we started having feedback.
Okay.
And so it looks like he's.
Am I still on mute?
No, we can hear you now.
We can hear you now. Couldn't hear you for quite a while.
Oh my goodness! Y'all gotta say something.
Yeah. Okay. So we're back. It looks like we're back in the saddle. I have another meeting just getting started, so I have to switch over to it. I'll let you guys go.
Okay.
Where's the last place that I was heard?
Oh, about halfway through.
Okay. So I guess design engineering. Did we hear that?
Keep going back.
Okay.
Hey, Alan, this is Mike Waltz at West Park. I think you were finishing the
design engineer.
Exploded view.
Oh, exploded view? Okay, cool. Right there?
Yeah. That's true.
Cool. Okay, cool. All right, sweet. All right, so then, okay, that's not too bad then. Okay, well then I'll just pick it up and try to hurry through. So exploded views, representation of the parts, gives me identification of each of the components, and then we can talk about the bill of materials. And so the bill of materials is basically a listing of the parts that make up an assembly. So again, identifying the individual components is going to be very important. One of the things that I have to think about is that this is literally every part in this assembly down to the screw. So whether or not I'm using a screw that's a 1/2 inch long or 3/8 of an inch, or the type of decisions that I have to make. This is like the not so glamorous part about it, but that's a lot of what it is. It's every piece of this assembly kind of coming through. And one of the things that's really been kind of made apparent by COVID is sourcing. You know, where are these things coming from? The pandemic has made us think a lot about supply chains and things like that. So where things come from and where we're getting our parts from is very, very important. I'll blow through this, and so we can ask more questions about this. But graduated high school 2002. Got an internship at Johnson Controls. Worked there. Actually had that internship before I started at Bradley. I got that internship through a program that helped minorities get internships in business and engineering. I got another internship at CNC Group, which was another company in the same kind of business area through a contact that I made at Johnson Controls. I got an internship at Dynamic Controls by searching for engineering companies in Peoria when I was still there. Got an internship at Rockwell Collins right before I graduated through my engagement in a professional organization, National Society of Black Engineers. Found them at their career fair. After I graduated, I left that internship with a job offer, went back to Bradley, graduated, was a mechanical engineer at Rockwell Collins for 3 years. Economy got weird, decided to move to New Jersey, worked for Fiberspan, hated it, was a bad experience, got laid off, decided to move to California, started hanging out at Hacker Lab, and then kind of started doing a little bit of freelance work. That led to opportunities at the Sacramento Public Library, started working at machine shops, and then that kind of translated into me thinking like, well, maybe I can do freelance work. And that led to AMW Design and kind of all the stuff that I've been talking about before, like working at Sierra College, the Disney show, the hackathon in Japan, and still just kind of figuring it out as I go. So what I want to kind of hit on with all of this stuff is you really want to develop a skill. And so that's we talk about skilled labor, manufacturing and related things are skilled labor. So what are you good at? What do you want to be good at? Specialization is what sets you apart in this, in this job environment. Because at the end of the day, what it's all about is that at some point, you're going to have to figure out how to do something, and then somebody's going to pay you money for it. So the more specialized that skill is, or the better you are at it, I guess, which you can think about specialization. You can be specialized at the skill that everybody has, but the better you are at something, the more money that you can get for doing it. And so I think the really important thing is that what I try to get across to people is that you want to take responsibility for that skill. You want to say like I want to get better at this because I want to move my career forward in this way. One of the biggest mistakes that I made as an engineer starting out was that I put too much faith in the company to make me the engineer that I thought I was going to become. And I think that, I just thought if I just showed up and did my job, then, things would kind of just go that way. And it was a lot of my experience that kind of led me to think, well, no, I have to drive this a little bit more. Even when you're starting out, specialization, because that's what's going to make you attractive to employers. If you can demonstrate competency in something that an employer is related to, then that's going to say, I can bring this person in, that I can get them up to speed really quick, and they can start generating value really, really quickly. And that's especially how manufacturers think. And even if you're going to work for yourself, you're going to need that competency and stuff to demonstrate clients so that they'll have the faith that you can execute on whatever sort of field that you're working with. So for me, starting out, it was AutoCAD. I learned AutoCAD at my first internship, and then that was always a good conversation starter. Like, no, I know AutoCAD. And then from there, I just learned the controls business and the construction and stuff like that. I could probably still get a job at a controls company. I mean, things are a little bit different, but I understand a lot about how the process works and things like that. So it's really that skilled labor that you really, really want to think a lot about, because that's what it pushes it. And it's kind of funny because I think about other mistakes that I made when I started out as an engineer. I thought that when I became, an engineer, I would just go to my job, work at my desk, and that would be it. But again, like I was speaking to earlier, there's definitely a collaborative nature to it. And I think one of the big things that kind of got me at the beginning was how much it was about like having meetings, having design reviews, talking about what I was doing, talking about why I was doing it, getting feedback on stuff things like this. And it again goes back to when you're working on a lot of projects, you're not doing them alone. You're going to be part of a whole. So there has to be some sort of communication and collaboration. If you want to succeed these things, you have to get better at that stuff. You're not going to get away from it. I mean, you can lessen it, but you have to your designers, you have to tell people this is why I think this is a good idea, and be able to kind of have those back and forth. So one thing that was suggested to me was to highlight some sort of project that was my favorite, and that has to easily be the Cineo Matchbox. This is one of my one of my first really, really big projects when I started freelancing, and I took it from concept to production. And this is essentially a small photovoltaic light that's used for cinema and photography. And the draw of it is that it gives a very, very controllable color temperature. So I worked with the designer and electrical engineer, and started out with the designer giving me sketches and me kind of turning those into concepts. And then we turned those into applications and assembly drawings. And I even did the 3D printed prototypes for it. But for me, that was a really kind of cool experience of just going the entire gamut from like, we have an idea to we're getting like, hundreds if not thousands of these things produced. So that was an amazing experience for me, and definitely one of kind of like it encapsulates the entire design engineering experience for me. So programs to check out. So, we talk about skilled labor, so how can you get your skills up? So a good place to start is Fusion 360. It's made by Autodesk. It's free for students. This is like one of those 3D programs where you can use and draw stuff. So you can create drawings and objects like the ones that we saw earlier. SolidWorks, Creo Elements Pro, CATIA, NX, which I believe is Unigraphics. Those are commercial level 3D softwares. Again, if you can get your hands on them, educational wise, things like that, those are good types of things. These are the type of things you can put on resumes. Like, I know how to use this program. I'm familiar with that. Even though we're talking about fabrication, Illustrator and Photoshop come into play. A lot of times there's more and more desire to kind of take like photos and manipulate the files so that they can use with computer aided manufacturing tools. Like, I get requests a lot to do like etchings and laser cuttings and things like that. So, and even like for machining. So there's definitely a lot to be had there. AutoCAD is just always going to be a fundamental tool. It's really useful. Even though primarily 2D program, there's a lot you can do with that. It's just an industry skill. If you can put AutoCAD on your resume, there's jobs that you can find where that's the requirement. Do you know how to use AutoCAD? Moving towards some more sort of the open source free range, Inkscape is an open source analog to Adobe Illustrator. It's a vector drawing program, very powerful. I use it a lot for manipulation. Again, kind of talking about these are kind of programs that help bridge the gap between something cool, like if I want to like 3D print like a sword from like video game, or like I guess like like Bleach's, like Ichigo's sword from Bleach if you watch anime, or like Cloud's sword from like Final Fantasy VII, you know, messing with that type of stuff. The new image manipulation program, GIMP for short, it's an open source analog to Photoshop, and it's again similar stuff where I can kind of take images from one place and kind of manipulate them, and then use these files with a 3D printer or a laser cutter or something like that. And then Blender is a 3D program and probably one of the most powerful open source software suites I've ever seen. People use it for like CG animation and rendering and things like that. Now there's kind of a line between like your tools, like your Fusion 360s or your SolidWorks for manufacturing, and then like your visual stuff, like Blender or like 3ds Max, or maybe you even heard of Autodesk Maya. But as we move further into computer-assisted manufacturing in these tools, these lines start to blur. And I think that there's definitely been tools that I've used where I've used Blender in some of my manufacturing workflows where I've tried to get more organic shapes than something that I was going to build. So I think that is about it for me, except for the technical difficulties, and I guess we can open it up for questions. Hello? Dean, you're muted if I can't, if you're saying something.
Thank you there. I was muted. So thanks, Alan, for the presentation. And thanks, everybody, for joining on here. I do have a series of questions that have been inputted already. So first question from Drew. What's your favorite type of drawing?
Like type of drawing? Like, okay, I guess there's a lot of ways that I can answer that. But for me personally, I like doing like a lot of monochromatic pencil work. This as far as like, you know, because I think I showed the drawing of like the classroom. So yeah, so basically pencils and just messing with shading and things like that. I don't trust myself with color yet. I'm trying to get more there, but color is really complicated in drawing. And I think one of the best design suggestions I ever heard was that if it looks good in black and white, then you know it's good. Then you can always kind of add color to it and things like that. But yeah, I like pencil, ink, monochromatic stuff.
Okay. Favorite thing about your job?
Favorite thing about my job. Favorite thing about my job is probably when I'm dealing with a client or an individual, and I guess the light goes on in their head that I actually know what I'm talking about. So I think the idea of like, you know, just the appearance of like competency, because a lot of times like it's about communication, and I think whenever you're working on a design for someone, there's a level of trust because someone is giving you money, be it a boss or a client, because you know something or you have skill in this area. And the thing I like about the job is being able to demonstrate that and to be able to create that value, and then for that person to unmistakably know that value is being created, so they're not going to complain when they get my invoice.
Okay, thanks. So good question for someone who's looking to the future. How difficult is it to find an engineering job coming out of college, and any strong recommendations to make yourself more marketable?
Well, I would say that none of it is easy, but I think the biggest thing that you can do to make yourself marketable, because I'll tell you right now, my grades were not good. They were good enough for me to graduate though. But a lot of that was that I was dealing with a lot. You know, I was didn't have really much financial support from my parents. I was working. I basically used my internships to pay for books. So yeah, there were reasons. But honestly, one of the best things you can do to make yourself marketable is internships. Experience. Yes, grades are important. Grades are very, very important. But you want experience. That shows employers that, number one, someone else has already taken the time to hire you and things like that. You've operated in a work environment, and that's really the biggest thing, is to have that history. Next after that would be a portfolio showing work or things that you've done. But I'd probably put, all of it is good, so you don't want to dismiss anything. But I'd honestly say that that work experience, having some sort of internship experience, especially field applicable to the field knowledge, would be one of the biggest things that you can do to make yourself more marketable.
Okay. So I think I've heard this question before, but tell us about your favorite video games and on what platform.
All right. Yeah, I think I slipped up and mentioned it this time around. So I'm primarily a console gamer. PS4, Incredible Mike, if you want to get rocked. Right now I'm playing Ghost of Tsushima, Destiny 2. I'm real big on Spider-Man. I'm real big on fighting games, Street Fighter, Skullgirls. What else? Trying to get into King of Fighters. I like RPGs. Final Fantasy, Persona series are really huge. Final Fantasy 7 is my most favorite game ever. I had to take like a week off to play when the Final Fantasy 7 remake came out. I've been waiting for that for literally like 15 years. PS4. I like strategy games too. I like a lot of action RPG games. I'm really into like Japanese stuff. I can speak, read, and write Japanese, so I'm into imports and stuff like that. So RPGs, action games, and fighting games are really what I like. And shooters a little bit. Destiny and like a little bit of Modern Warfare, but I don't know. I think that's a young man's game.
Cool. All right. Question from Julian. How expensive is your design work?
How expensive is my design work?
Yeah.
It depends on the state of the. So I guess the cost of my design work is how hungry I am and what the market can bear. So generally, when I have generally, depending on what I'm doing, what the state of things are, and how hungry I am, I've charged hourly rates anywhere between $160 an hour to $40 an hour. So I'd probably say right now my floor is pretty close to 40. I mean, I do the homie hookups every once in a while, but it really just depends on what I'm doing and who I'm doing it for. And like one of the things is that just being honest, like I got into this stuff just because I needed to make a living, and so it's been kind of a learning experience for me. And honestly, like I can sit here and say like, oh, my rate is $160 an hour, which sometimes it is, but honestly, we're in the middle of a global pandemic right now, so I got to get this money. So it just kind of, that's just the reality of it. So probably anywhere between 160 and 40, depending on what I'm doing.
Cool. So which project are you most proud of?
Most proud of? Easily, I'm most proud of the Matchbox. Again, just being a product that's something that unmistakably that I can say that my fingerprints were on from beginning to end. And what's even really cooler about it is that there's I have an artist friend of mine that I collaborate with a lot of things on, and he was actually trained by Sid Mead. Sid Mead's this really famous concept artist. He did stuff like Blade Runner. He did something I think like Victory Gundam or something like that, or no, Turn A Gundam, I think it was. So he's done like all like this design. So he passed, I think, probably about like 6-9 months ago. But anyway, about 5 years ago, about now, I actually got the chance to meet him. And I actually took some of the Cineo guys down there with me, and they actually showed him the Matchbox. And he was actually using my Matchbox probably up until he passed to light his work. So it was really kind of cool that this little dinky, well, not this dinky thing, but this thing that I made was really that this world-class designer saw value in that and was using that. So it's not one of those things that I can really explain to people, but because I know who he is, and just that's a really huge point of pride for me.
Nice light question. Tell us about your experiences of being on the Disney show.
Okay. The Disney show was quite honestly the hardest, was one of the most difficult things I've done in like the last decade. TV is crazy. We shot for 3 days, 12-hour days. We did the first day, which was like an intro day. Then we did our 3 build days. Then we took a break, and then we shot the final day. And honestly, I look back on that, and I am so I'm happy I had the experience, but I let the pressure of it get to me, and I made a lot of mistakes. I did the best that I could, but for me, the Disney, I've been freelancing for probably about the last, I don't know, maybe going on 7, 8, 9, maybe even 10 years now. It's been a while. What did it be, 2005? No, so 6, 7 years. 6, 7 years. But I haven't worked officially in the industry for a while. And so when I left Fiberspan, I was at a really weird place professionally. So for me to be on that show, because it's like the Disney Channel. I can't I can try to play humble as much as I can about that, but I'm on freaking Disney. Even if I didn't win, I still on Disney Channel. So for me, it really kind of showed me that how far I've gone, but also how far I have to go, because I was good enough to be there. But like I said, the pressure got to me. I made mistakes that I shouldn't have had. But at the same time, I really have to take value in the fact that I was good enough to be there. And as much as I want to complain about mistakes that I made, I represented well. So I think that having been almost about a year away from that, it's really pushed me to kind of be like, no, you're good. On one hand, to be like, to have the self-confidence to say that I'm good enough, but also to have the self-awareness to be like, there's a lot of things that I need to work on and I need to continue doing on that. Those are really positive experience. Very, very stressful, extremely stressful. Cameras everywhere.
All right. Let's see. Next question. When you design a product, how do you research what's already in the marketplace or in production by others?
I mean, honestly, the internet. That's really the number one thing. A lot of it is just also kind of personal experience too. If it's something that I'm interested, I'm real big on books. I got books on design stuff. I got just things like that. So really, just print reference. I think as I'm looking at stuff, I'll find something that I'll just keep as like reference, and the internet just makes it super easy because you can just take a picture and just keep it. But a lot of it is just using my own knowledge of it. With some stuff like what's a good example? Well, I was like, for example, I do. This is a bad example, but not a bad example. But I have someone a while back who wanted me to do a kind of game controller. So I'm play video games all the time. I'm very familiar with game controllers. So you take one apart and see it and see what makes it tick. You look at images of it. So it's just finding as much reference or just finding as much information as you can about it, and just kind of going from there. I think one of the things that's really interesting about design is that you talk about design intent, and once you get your head kind of working in that way, you can kind of, by how you interact with an object, you can tell a lot about what the process was of it being designed. Like for example, I don't know if everybody has cell phones now, but if you think about a cell phone, think about how a cell phone like feels in your hand. Think about how much space it takes up. Somebody has to think about that. When you had the old phones where you actually picked them up, maybe you've seen them in the movie now because nobody uses them anymore, and you hold them up against your ear like that. That space in between those two receivers is designed specifically to fit, an average hand. So there's a lot of, when you really kind of get into design and really think about building and really kind of start thinking through your process, it's amazing how much of kind of like a narrative kind of comes through. And once you get used to looking at that stuff, you can start to kind of think about, identify that narrative, and then that kind of informs your design. So a lot of times I'm looking at reference material, but I'm also, through the material that I'm looking at, through what I'm looking at, I'm trying to kind of get my head into the person of who built it. And that's even true with bad design. Because even with bad design, somebody had to, there's a story there.
Okay. On that note, have you ever worked with Ideal? Is it Ideal Lab?
Oh, Ideal? No, I have not.
The big design lab down the Bay Area.
But that's one of my huge inspirations, and that's one of the, when I was in high school actually, they showed us a video about Ideal. So I've never worked with them, but I'm very, very familiar with them, and it was definitely one of my huge influences on what I do and how I do it. So a huge amount of respect for them, what they do.
So in any of your design work, have you ever had to do what's called patenting research into products?
Yes, I have.
Talk about that process.
Yeah. Yes, I have had to do some patent research. It's never, a lot of it was kind of preliminary stuff because, again, going back to what I said before, making things is hard. And so patents are so personal. This is my personal opinion. Patents are tricky because one of the things about design work is that you're dealing with somebody's perception. And I think the idea that people have is that I'm gonna make this thing, I'm gonna patent it, and then I'm gonna make it and then I'm gonna make a whole lot of money off of it. And that can't happen. But patent is an expensive game. You think about like some of the stuff that like Google, Apple, and Microsoft are doing, where you have like these lawyers kind of fighting and things like that and patent infringement. And so what really makes a patent valuable is the will to enforce it. And that requires time and that requires money. And for me personally, I'm always going to focus on time to market quicker than I am going to be on defending a patent. But then again, if Microsoft or Google wanted to throw me some money and say, hey, we need deals and patents, I'd be about that all day. But so a lot of what I've done with patent research has really just been kind of seeing what's out there, and then kind of trying to see how a design can either line up with or make sure we don't infringe on that patent. But a lot of it, as much as I hate to say this, you hear like move fast and break things. One of the things is, unfortunately, when it comes to a lot of this stuff, it's better to ask for forgiveness than it is for permission. And that's kind of where I kind of feel it on patents. They are valuable, and I don't want you just patents out of hand. I just have a very realistic objective about the space I occupy. But it has come up before.
Okay, so I think last question. On a lighter note, Mike would like to know if you like jazz.
I do, yeah. I like jazz. When I was in high school, I was really, I was really into Louis Armstrong, Ella Fitzgerald. I had one of the things, Dizzy Gillespie, Miles Davis. Although some of his later stuff gets really kind of out there, but it's cool, whatever. Coltrane, a lot of that when I was in high school was actually my work music, and I'll still kind of use it now. I think Grover Washington Jr. is still one of my favorites too. So yeah. I'm down with the jazz.
Cool. All righty. Well, I think, this is about the end of our session.
Cool.
I'd like to thank Alan again for taking time out today to make himself available to all of these high school classes. It's been really wonderful experience. Thanks to all the teachers and the students for joining in. A lot of great questions.
And if any of you guys have questions, feel free to email me. I think my information is in the presentation. Feel free to email me, ask me about whatever. So cool. And or if you want to get rocked on PS4, whatever.
Right. And on a final note, these sessions are all being recorded, and we will be making the recordings available to all of the instructors to share. I know that you haven't had a chance to allow your classes to watch all of them, but there were 14 different sessions going on today between 7:45 and now. So hopefully there's some valuable content here that you can share with the students going forward. So,
cool. All right, well, it's been a pleasure.
Thanks, everybody. I really appreciate your time.
Hey, this is Mike Waltz of West Park. Alan, thanks. I was here all day. These are great. And Dean, thanks for putting it together.
Right.
Appreciate it. Thank you.
We're looking forward to getting out to the schools here in the future.
Yeah, it'll be great. It's going to be fun when we can play normally again. All right.
Most definitely.
Exactly.
Thanks.
Thanks, guys.
Okay. Thanks, everybody. Thanks, Chris. Appreciate it.
Thanks. Yeah. Hey, Chris. Yeah.
Hey, Alan. Thanks a lot. I appreciate it.
No problem. Anytime.
You got to get up to Antelope High pretty soon. Play with.
Yeah, most def. Yeah. When we can make it work, right? Yeah, I'll come back out there and see you, man.
All right. Thanks, Alan.
No problem.
Bye-bye.
Okay. Be well.